Hey guys, I'm Alex with CIMsystem. In this video, we're going to walk through the steps for processing hybrid abutment and screw-retained crown cases within MillBox. I'll show you the workflow, and we'll go through the major criteria that's required in order to process these case types effectively. Let's get into it. All right, so the first thing we're going to do once we have MillBox open is go into the top right-hand corner and click on New Job. And we're going to go ahead and give our job a name. I'm going to call this Hybrid 1, 2, 3, and we're going to click the blue check to proceed forward in the workflow. The first thing I'm going to do is going to be to select a machine. So I'll select CIMsystem. This is just a generic machine that we have, and I'll make sure that I have the correct tool package that I want to have. I can see my tool packages if I click on this icon right here with the arrows. I'll make sure that I have the tool package that I want selected, which I do, and I'll go ahead and click on the blue check. I'll select my material. In this case, I'm going to select zirconia, and I'll select the fixture. We'll just choose the normal 98 millimeter standard disc holder. Click the blue check to proceed forward. MillBox will open up the Import STL window. We can go ahead and we can start importing our files. I'm going to import a hybrid abutment part, so I'll go ahead and I'll look through my STL files, and I'll select the one that I want, and we're going to go ahead and begin processing this case as a hybrid abutment. I'll go ahead and I'll click on the queued import, and then we'll go over to our screw-retained crown, and we'll go ahead and import that as a hybrid anatomic. Now, it really is important that we select the proper restoration type here. You don't want to go ahead and select abutment, for example, because an abutment part is going to be different than a hybrid abutment. A hybrid abutment is going to be seated down on a tie base. It's going to be cemented down onto a tie base. It's got a pass-through screw channel, and it does not have a hexed or a tri-lobed engaging interface or a screw stop. So abutment, on the other hand, does have a hexed or a tri-lobed engaging interface, and it has a screw stop that's going to have to be milled out using possibly a T-tool or some different operations. So if you're looking for information about how to mill out abutments, how to replace interfaces, if you've got something with a Rosen screw power ball, go ahead and check out our other videos on the platform for how to process abutment parts. So, but you want to make sure that we're importing these parts as the proper restoration type. So as I imported this screw-retained crown, I really did need to make sure that I imported that as a hybrid anatomic. And that's because if I import it as a hybrid abutment, it's going to detect an additional secondary finishing axis. And that's because on a hybrid abutment, we're going to be seating down a top cap afterwards. And so MillBox is going to have an additional finishing operation on all hybrid abutment parts that's going to be based on the insertion direction for that top cap. So you really don't want to select a hybrid abutment on a part with anatomy. For those case types, we're going to want to select hybrid anatomic. And really why is because that secondary finishing axis might cause some additional undercuts on your part. So we do just want to make sure, again, to select the proper restoration type for our hybrid abutment or our screw-retained crown as a hybrid anatomic. Okay, now that I have both my files imported, we're going to select our stock. We're going to go up to the top here, see that our minimum thickness required is going to be 15.69. So I can go ahead. I've got 2 used discs in my partially used stock library that are 16 millimeters thick. If I wanted to create a new disc, I could do that by clicking the green plus here, but I'm going to go check out these partially used discs and see what we've got there. We'll click on that too. And that's going to go ahead and pull up our partially used stock library. I see that I have one disc that's been pretty used up, 37% used. I can definitely fit these 2 parts in there. Or I could go and select this other disc that's got 9% used. Now MillBox is always going to show you the most used disc that these parts will fit into first. And so I'm going to go ahead and use MillBox's suggestion and click on the blue check to proceed forward and allow these parts to automatically nest into my disc for me. Now you'll notice right away that MillBox has already done quite a bit for us. It's already detected all the major curves and surfaces that we're going to need, and it's already put support pins on our part automatically, and it's auto nested our part inside of the fixture. So this is great. We might be able to actually process this case already if we were to just check a couple things. But let me go ahead and show you now the 3 requirements, the things that we need to consider in order to properly mill out these cases. So there are 3 requirements for successfully milling hybrid abutment and screw-retained crown cases. Those requirements are the reg caps. You want to make sure the reg caps are present on your part and they're properly designated. You want to check on the designation of your drilling axis curve for your screw channel for the drilling operation. And then you also want to make sure that the margin curve is present at the base of the abutment. So these are the 3 3 things that you really do want to watch out for, that you want to take into consideration before just going ahead and sending this to the mill. So let's take those one by one. So first one, the reg caps. What are reg caps? Reg caps are here, you can see them, the little reg caps, the red circles that are present at the top of our part along the surface. The reg caps are going to be at the top and the bottom of the drilling axis curve, and they're going to be responsible for preventing a tool from going down into the drilling axis channel before or during roughing and finishing operations. So you definitely want to make sure that you don't have your tool go down. Let's say the tool is coming across the surface of the part here in a finishing operation, and the reg cap is not present, then the tool is going to jump down inside of the part here, and that's going to cause a potential tool breakage. It's going to cause potential part breakage, and so we want to avoid that. And so these reg caps are going to be placed on the surface so that when we come right here to where the screw axis channel starts, this surface is present, and we just continue milling along the surface as so. So in order to see both reg caps, because there are 2 of them, we want to go ahead and press the number 9 key to go ahead and toggle our translucency. The number 9 again will show you the wire mesh view to see the mesh of your STL. And to get back to the opacity view, you just go ahead and press the 0 key on your keyboard. We press 9, we can go ahead and we can see both reg caps. Now the positioning of these reg caps is important. We want to make sure that the reg cap is flush with the top of our part up at the top. Reg cap, and then we also, for the bottom, we want to make sure that the reg cap is present at the base of the screw axis hole. And in this case, we do have our reg cap a little bit up inside the screw axis channel, but it's not far enough to worry about anything. And so I'm just gonna, I think we can just leave this. This one's not a problem. But however, if we did have our reg cap somewhere down here, for example, then the MillBox is not gonna rough or finish out any of the area here. And so really we're gonna have a bulk of material left over if we have that outcome. And we're not gonna be able to seat our part properly, and we're not gonna be able to fit the screw through because it's gonna be blocked. So we do wanna make sure that the reg cap is either up a little bit inside of the screw channel, just a little bit, or right, preferably at the base of the screw axis hole. And so now let me just go ahead and show you how we can properly designate these, how we can manually designate these if for some reason we don't have what we need upon import. We can go ahead and we can go to Tools, Curves and Surface Tools. I'm going to delete these out first of all. We can click on Delete Curves or Caps and Surfaces. Click that a second time and you're going to have just the curves, and then click that a third time and you're going to see the surfaces as well. This makes it a little bit easier for you to be able to delete these. Click on the curves or the surfaces that you want to delete. In this case, I'll delete the reg caps, and then we'll go ahead and we would do the same thing. If we want to designate these, we would go to Tools, Curves and Surfaces, and then we'll go to Add Reg Caps. MillBox gives you 2 options for adding these reg caps. The first is going to be from a single click. We're just going to select an area on the inside of the screw axis hole. We'll just click right here, and MillBox will place both the top and the bottom reg cap. The bottom reg cap looks like it's great. It's actually right at the bottom of the screw axis hole. So this is perfect. We could go ahead and we could proceed with this. Additionally, I'll show you how we can draw on the reg caps if we go ahead and use the by drawing feature. MillBox will give us the ability to draw this on using our little tool here. So we can go ahead, and if we were to get off like that, we'll come back and we can close. If we were to get off like something like this, we can go ahead and click on the black little dot, and we can snap that over to the exterior, the perimeter of our circle here. Once we're happy with what we've drawn here, then we can go ahead and click Exit, and MillBox will place the reg cap on the surface of our part. Now notice that it only places the reg cap that we drew, so we do need to draw all of our reg caps if we need to use this tool. So I'll go ahead and we'll draw the bottom reg cap now. Add reg caps by drawing, select a point, and we'll begin drawing. Okay, and we can click Exit, And MillBox is going to draw that red cap on for us as well. And we can go ahead and check to make sure that it's at the base of the drilling axis channel, and it is, and it hasn't gone down inside of the cavity here. So we're good to go. That is our first criteria. We have met it, and we're good to proceed. Okay, the second criteria is we're gonna wanna go ahead and check on the drilling axis curve. I'm gonna turn off my red caps here now that we've done that. The drilling axis curve is going to be this green line right here. It's going to be a cylinder if we click on it. And this is going to be the curve that is responsible for determining the drilling operation. So after roughing and finishing, when we go to the drilling operation, MillBox is going to send in the tool to mill out this screw channel here. This green curve determines the diameter of the screw channel, the height or how far down this screw channel is going to go, where it's going to start, where it's going to stop. And so we can actually adjust those things if we don't have a proper result in the cam right away. So for example, let's just say that we didn't have the right height and it was somewhere like this. We can toggle our part view with this little icon right here if we need to. But something like this would not be acceptable if we had, if it had imported like this. Because you'll notice that the drilling operation isn't going to start until we're a little bit into what we've designed for the screw axis channel, which means that we could possibly have a tool break, we could have some other problem if we go ahead and leave it like this. So we would want to go ahead and adjust this. We can go ahead and change our transparency, and I could go and shift this until it meets the top of the screw axis hole. We want to make sure that the drilling operation starts right where it's supposed to. And in the bottom, if we were to have something like what we're showing here right now, this would be a problem because the drilling operation would not go all the way through the screw axis channel, and then we would have a bulk of material remaining right here, and we would not be able to put our screw through because we would have a stopper in it. So we would need to, in this case, increase the height of our drilling operation, and we could go past if we need to. That's fine. Something like this would be perfectly acceptable, and really there we go. That's the drilling axis curve. Now if we need to designate this curve, if it's not present or it's just something's wrong with it, we can go ahead and we can delete that curve by going to Tools, Curves and Surfaces. I'll click this twice so that we show just the curve, and we'll delete it by clicking it. Then to detect the cylinder drilling axis detection, again, we're going to go to Tools, Curves and Surfaces, and then we're going to go to cylinder or drilling axis detection. Now for this one, again, we have two tools for a single point. We can just go ahead and click on a single point, and MillBox is going to automatically give me its suggestion for the drilling axis curve. Looks great. If I want to do this by 3 points, I can do that as well. We'll select the by 3 points option. I'll go ahead and toggle my translucency by clicking 0. And then we just need to select 3 points that we think are about the same height in our part, and then we can go ahead and check and see if MillBox gave us a good result. Let's see. Yeah, it looks good. It's present at the top here, and let's go check the bottom. Yeah, looks great. So with this, we're able to proceed on to the next requirement. So the third and final requirement. Our third requirement is going to be to make sure that the margin curve is present at the base of the abutment. Now, this curve is going to be present both on our hybrid abutment and on the screw-retained crown here. We're going to want to make sure that we have this pink curve, this pink arrow. What's this for? Well, the margin curve is present. It's going to determine the insertion direction for milling out the tie base area of the cavity. So this insertion direction, if you click it, you can go ahead and you can see that view directly. Oops, looks like the part moved on me. I can go ahead and change that. But yep, the pink curve here then is going to be the insertion direction for milling out the tie base area of the cavity here. So if this data is not correct, you are going to want to correct that, because you might get some unwanted undercuts and you won't have a proper fit. Now MillBox has detected this properly and everything looks good here. I'm not seeing any major undercuts on the part. So we can proceed, but if we wanted to, or I'll just show you how we can designate this inside the cam. We can go to Tools, Curves and Surfaces. Again, delete Curves and Surfaces. I'll click it a couple times so that we can make sure that we delete only the curve that we are needing to delete. Click on the pink line there. All right, and in order to designate this margin curve, we'll go to Tools, Curves and Surface Tools, and we'll go to Margin Line. Now this is the same tool that you use on Crown and Bridge, just for a different purpose here. We're not going to use the stump margin because that's for a different part type, but we can use the detect cavity or the cavity margin option, either one, whatever you prefer. I prefer the detect cavity because it usually works great. We can go ahead and just select the width for our margin line. I can leave it as is, and we'll just select a point, and we'll click a point on the interior of the cavity, and MillBox will determine the proper direction to mill out the cavity from in order to minimize undercuts and make sure everything properly seats. And if we want to try this another way, we can go ahead and we can draw on the cavity margin line. I can click the cavity margin option, and we can go ahead and start drawing this on. Same tool as before, so we'll just go ahead and start drawing this on. We'll come back for that. And there we go. And we can go ahead and click the blue check once we're happy. And MillBox will determine our insertion direction and place that margin curve back on there. So with that, we've got all three of the criteria that we need. We can go ahead and we can check our other part here. We can make sure, yes, red cap. Yes, the red cap is present. Looks like it's fine. It's a little bit inside, but that's okay. We can go ahead and we can check to make sure our drilling axis channel, yes, it goes from there down through. Yeah, it goes all the way, and the margin curve is present, so we are good to go. That's that. Now with this, we're ready to go. We could go ahead and send this to the mill. So before I do that though, let me go ahead and check and make sure that we don't have any additional undercuts, that I'm happy with the placement of my parts within the disc. Yep, I don't see anything that won't work. We do need to add one support pin to this screw-retained crown here. I'll add it right there. It's semi-cuttable, which means that at the end of milling, MillBox will just go ahead and cut away half of that, that pin for me. With that, everything looks like it's ready to go. So I'm happy with this. So I'm going to go ahead and we'll click Start Mill. And we can go ahead and click on Save Toolpath. MillBox is going to bring up any additional milling options for this job. So if we want to see a preview of any of these milling options, we can go ahead and do so by clicking on the eye icon over on the right hand side. That's going to show me a preview of what that toolpath looks like. So I can see the different toolpaths here. This is for the external undercuts on the cavity, 3+2. And now if we're happy with everything, as I am here, then we can go ahead and we can just proceed forward. I'm going to click the blue check to go forward in the workflow. So now MillBox is going to go ahead and just calculate everything for me. We're going to see one more additional window. We're going to see a tools table where MillBox is going to indicate to us where the tools need to be, what tool slots they need to be in, so that we get a proper result when it comes time to mill. And that's it. If you follow these steps and you make sure you meet these requirements, you have what you need to properly process hybrid abutment and screw-retained crown cases in MillBox. If you found this video helpful, check out the links in our description. We've got other tutorials and training videos like this. Also, we've got help.CIMsystem.com. We got a link there. Go ahead and check out help.CIMsystem.com. We've got articles, frequently asked questions, and a full MillBox online manual available for you to take advantage of. So go ahead and check that out. Thank you guys for watching. Ciao.